Hello everyone, welcome back to the CIA video series for this book. In this video we're going to be taking a look at chapter 9, which is focused on exploiting the Windows registry. Now, we've covered quite a few techniques within this chapter. I'm going to be taking you through some of the most important techniques that you should actually take note of, as you will run into them frequently, or you will run into scenarios that require the usage of these techniques frequently. So the first technique that we're going to be exploring is the process of exploiting Autorun programs. Now, we are going to be using the Windows 7 virtual machine, more specifically the vulnerable Windows 7 virtual machine that we set up in the previous chapter and in the previous video to actually demonstrate these techniques. And we'll be using the same vulnerable virtual machine for the next couple of chapters that involve Windows privilege escalation techniques, right? So let's get started by taking a look at the process of exploiting Autorun programs. Now, I already have access on the target system, and if I display my current user, you can see I'm currently using the user, which is an unprivileged user, of course. And of course, let's start talking about Autorun. So I've already explained within this particular chapter what Autoruns are. Autoruns are essentially a Windows feature that is used to automatically start applications and services during the system startup. So this is frequently set up by administrators or users or by programs themselves. And what this does is it actually sets up programs to be executed automatically when the system boots up. All right, so the Autorun feature is disabled by default in newer versions of Windows like Windows 10. However, Microsoft has provided the users with the ability to actually enable it. So this is a feature that is going to be available to be exploited in the event that you do have vulnerable programs or Autorun programs. And it is a feature that I have seen personally being deployed in enterprise environments before. And let me take you through the process. So the exploitation process for this particular technique goes as follows. We firstly need to identify the Autorun programs running on the system. And secondly, we need to, of course, we then need to identify whether we can make changes to the actual path of that program so that we can replace the actual executable or program with our own custom program that when executed on the system startup, when a user logs in, will actually provide us with admin privileges. So in order for this technique to work, we need to find an Autorun program. Secondly, we need to have the right permissions for the program directory. And what that means is we can actually replace that program executable with our own custom payload. And thirdly, we of course, this technique will rely on the process or the actual eventuality of the administrator user logging in. And once they log in, they'll be prompted to execute, or that particular Autorun program will be executed and will therefore provide us with an elevated meterpreter session. All right, so the first process will involve identifying whether the actual Autorun programs running on the system, and this can be done through the use of the Windows registry. So we can run a registry query to actually check for the Autorun programs that are currently running on the system. So I'll just paste it in. Again, this is highlighted within this chapter. So there we are. We can see that we have two Autorun programs. We have the VirtualBox program and the vulnerable program called My Program. And you can actually see the path right over here. And in this case, it is under program files, Autorun program, program.exe. So then the next step will involve identifying the actual permissions just to see whether we can actually make changes to this directory, or we can actually upload our custom executable to this directory. And we can do that through the use of a utility called AccessCHK. AccessCHK is part of the Windows sysinternal suite, and the link to that has been provided within this chapter, more specifically this section. So you can actually download it onto your Kali VM, and then transferring it to the target is as simple as using the certutil utility or using the upload feature that is built into Meterpreter. So I already have AccessCHK downloaded and transferred to my target. You can see I have AccessCHK64.exe. Now, I've mentioned this previously. You don't want to save any of your exploit or enumeration executables or tools into directories or folders that are frequently accessed by users on the system. So in order to avoid detection, always make sure that you upload your exploit code or your exploits into a directory that's not frequently accessed. That'll typically be the temp directory in Windows. Now, for this particular demonstration, I'm uploading it to the downloads directory so that things are, kept as simple as possible. Right. So that being said, what we need to do now is, of course, we need to check the actual permissions for this particular path here, and we'll use access chk to do that. So in order to do this, we're going to say we're just going to execute access chk64.exe, and we are then going to say we then need to specify or provide the actual permissions or the listing of permissions that we want. So if I just type in access chk, you can see we want to show the objects that have write access. We then want to then to output verbose information, and we want to suppress any errors that we get. So we are going to say access chk 64.exe, so wvu. So we're using all of these three flags in conjunction with each other, and these three will essentially show us the objects that have write access, and will also display important information because we're essentially enabling verbose output. We then need to provide the path that we're interested in here. So wvu, and the path that we're interested in is under the C drive, and it's under program files. There we are. And we then say Autorun program. We hit enter, and it's going to give us the actual permission. So you can see that for everyone on the system, we have read and write access. The NT authority system or users with NT authority system privileges also have all access, as well as administrators on the system also have all access, which means we can actually replace program.exe with our own custom executable called program.exe that will essentially generate with MSF Venom to provide us with a meterpreter session, an elevated meterpreter session. All right, so of course the next step will involve using MSF Venom to generate this custom program.exe. So I'll just head over onto my desktop here. I'll open up a new window, and I'll just remove the one that I'd created before. And in order to generate it with MSF Venom, again, you can use the instructions provided within this chapter. I'll paste in the instructions there. You can see it's going to save it as program.exe. So the name has to be the same, otherwise it'll not be executed. Right, so for the port, the listening port, we will say 4443, and we then want to provide the Cali IP, which is again, in my case, 10.10.10.5. In your case, it'll be different. And then we hit enter, and that is going to generate our custom program.exe for us. And the next step will involve uploading it to the target. All right, so in order to transfer our program.exe program.exe executable onto the target, we can actually just utilize the meterpreter upload feature. So what we want to do is again, we want to head over into the actual directory here. So we'll head over into the there we are, and what we want to do is we want to head over into program files, and cd autorun program. Right, so cd autorun, let me just type that in correctly, autorun program, right? And we then want to head over, there we are, we can see the original executable. So again, make sure you've taken a backup of the original, and all we need to do now is simply say upload, and we specify the location of our custom program.exe, which is our desktop, so program.exe, and there we are. It is going to do that for us, and if we list that out, you can see it's actually replaced the current one. Fantastic. So now we need to set up our listener, right? So I'm just going to set up my listener here with Metasploit again, MSF console, there we are, and we'll use the exploit multi-handler and set the payload to the one that we actually use to generate our payload with, or the payload option. So use exploit multi-handler, set payload, Windows x64 meterpreter, reverse TCP, right? And we'll show options. We then want to set the show options. Set the L port to what we had set when we were generating our custom program.exe, which was 4443. Set the L host to your Kali VM IP, which in my case is 10.10.10.5, and then we hit run. So the next time that the administrator user logs in, we should actually get we should actually get an elevated meterpreter session. So I'm just going to show you how this looks like. I'm going to switch over to my Windows VM in a few seconds. All right, so I'm back on my Windows VM, and if I log in to the user with admin privileges or the administrator, so let me just log in here. We'll give that a few seconds, and that particular Autorun program that we uploaded should automatically be executed, and we should get a reverse shell. So if I switch back to my Kali VM, we should actually see that. All right, so I'm back on my Kali VM, and as you can see on our listener, we were able to get another meterpreter session that we are opened, and we're now logged in as the Windows 7 user, which is a privileged user. And of course, you can confirm this by typing in net local group administrators to list the members of the admin group. And you can see that the user Windows or Win 7 is part of the administrator group, and therefore it has administrative privileges. And that is how you can elevate your privileges by exploiting the Autorun functionality. Now, as I said, this is an extremely nuanced technique that will, of course, depend on the fact that an authenticated user actually has to log on. So you may have to wait a while, and you need to keep your listener running so that you can actually get the session back, or you can actually get the meterpreter session whenever the admin logs in. Once they log in, you should be able to get access. You should be able to get privileged access. That being said, let's move on to the next technique. All right, so the next technique we're going to be taking a look at in this particular chapter is the process of exploiting weak registry permissions. All right, so this technique will involve identifying and modifying the registry values of a particular service with an unprivileged user account. Now, typically, writing or making changes to registry values of a service is typically limited to administrators or privileged users on Windows systems. However, you may come across services that have actually been configured or misconfigured that can allow unprivileged users to modify the values, the registry values of that particular service. So, as I mentioned within this particular chapter, the registry can be used by services and programs to store data. And one of these, these important pieces of data is the image path, or within the Windows registry, a service will typically have a value called image path. Now, the image path simply refers to the application path of the particular service with the executable that is actually required to run the service. Now, we can actually leverage this vulnerability to modify the image path or the application path of a service and replace it with our own custom path that contains a custom executable that will give us an elevated session when the service is restarted, right? So that's very, very important there. Now, of course, it's also important to note that, in order for this particular technique to work, we should have the adequate permissions to actually restart the particular service, or the actual vulnerable service, so that we can get it to execute our own custom executable, right? So the first step in this process will involve, as I said, identifying the list of services whose registry values can be modified. In order to do this, we're going to be using the WinPeas utility. So I already have transferred it to my target, and you can see I'm still running as the unprivileged user here. And I'll just spawn a shell session. And if I list out my files on my desktop, you can see I have the WinPeas executable. So, we can run the WinPeas executable, and we want to limit it to services info so that it only displays vulnerable services. So services info, we hit enter. And right at the top, you can see we have the reg SVC, so insecure registry service, and you can see possible DLL hijacking in this particular folder, right? So if we take a look at modifiable services, or this option or this particular section here, looking if you can modify any service registry, you can see that we can actually modify this particular the actual reg SVC service values because it actually stores data within the Windows registry. So given that that is the case, we can actually replace the executable with our own custom executable, right? And in order to do this, what we're going to need to do is, of course, number one, generate our own custom custom executable. So I'm actually going to do this right now. Now, within the book, we uploaded it to our temp directory. So if I just head over into cd temp, there we are, and we don't have any files within the actual temp directory there. So we are going to save our custom executable within this particular directory, right? So I'll open up a new terminal window and we'll generate our we will actually generate our own executable that'll again provide us with a meterpreter session with MSF Venom. So I'll paste in the MSF Venom options here. I'll just provide our own port here, so 4444 for the L port, and then I'll replace the L host here with my own Kali IP, which is the listener IP, of course, and that is going to save it onto let's save it onto home Kali and onto our desktop for us so that we have it easily accessible. I'm going to hit enter, and that's going to save it. We're just going to call it shell.exe, right? And of course you want to rename it to something that's not easily detectable. Right, so that's saved on our desktop. There we are, and we'll be hosting that shortly. So we now want to actually upload it. So just to keep things simple, we can actually just use the certutil utility, and we'll set up our local web server using the Python module simple HTTP server, and we'll run it on port 80. There we are. And we will then use the certutil utility in conjunction with URL cache, and we'll say we want to download the file from the Kali IP or the Kali VM, and we say the file we're looking for is shell.exe, and we'll just save it as shell.exe, right? So shell.exe, there we are, and that should actually save it for us in the temp directory. There we are, that's done. So we can actually close that there, and instead of doing that, let's actually set up our handler so that we have that ready. So I'll run MSF console, and we'll give that a few seconds to start up, and we'll use the exploit multi-handler, set the payload to Windows x64, similar to the payload options we set when we were generating our shell.exe, meterpreter reverse, TCP. So let's see if I type that in, meterpreter. Right, so let's hit enter now. Show options, set the L host to our Kali IP, and set the L port to the port we actually set, which is 4444. Hit run, and now we have our listener running. So what we need to do now is we actually need to modify the actual registry value or the image path value for the target registry service to the actual custom path of our custom executable that we actually generated. So we want to change the image path of the reg SVC to our own image path, which in this case is going to be under the temp directory, and the executable name will be shell.exe. So I'm just going to copy over the registry command here, which will actually add it. So you can see registry add, and it will add the value to the reg SVC service. And what it's doing is it's setting the image path to the C drive, the temp directory, and the executable to shell.exe. So we hit enter, and it's going to say the operation completed successfully. And now, whenever the reg SVC service is restarted or started, we are actually going to get admin privileges or administrative privileges, right? So again, there's multiple ways that this can be done. Either the administrator will start it, or we can actually start it. So if we say sc start reg svc, we hit enter, and you can now see we get a meterpreter session, and we should actually have administrative privileges. And if we list out the privileges with get use ID, you can see we have NT authority system privileges, and we've successfully been able to elevate our privileges by modifying the registry values of a particular service, more specifically the image path registry value of the reg SVC service. And of course, in this case, you can see that it actually failed primarily because I terminated here. But again, I can actually just, if I just exit from this session and just run it again, and I say sc start reg SVC, and I should get it again. And there we are. All right, so that's pretty much all the techniques that I wanted to cover for this particular chapter, and I'll be seeing you in the next video.